mode.
Good morning, afternoon, and evening to our audience today. Welcome to the latest webinar hosted by Device Authority and Cumulocity. My name is Rosa Lenders, and I am very pleased to welcome our key speakers for today, Philip Hooker and James Penny. Philip is Director of Strategic Programs at Cumulocity. He was the instigator of one of the innovation initiatives inside Nokia, which became Cumulocity. He has over 20 years' experience working for and with the CXOs of global organizations in many sectors, including Orange, Nokia, Barclays, Wipro, and PRS for Music, on numerous strategy, business development, and program delivery topics. James is a technical architect at Device Authority. He has worked in security for over 10 years, architecting and deploying complex security and encryption projects for organizations across all industries, including financial, pharmaceutical, and UK agencies. He has also designed several apps which are featured on the Apple Store. We expect the webinar to last approximately an hour, and you will be able to submit questions via the chat window in the GoToWebinar control panel throughout the session. We will try to answer as many questions as possible at the end of the webinar. Contact details are included in the final slide, so if we are unable to cover your question today, or should a question arise afterwards, please contact us. A recording of the webinar will be made available tomorrow on the Device Authority website, and everyone who registered will be emailed the link. I shall now hand over to our speakers, Philip and James.
Thank you, Rosa. So, manufacturing and process industries heavily invest in research and development to both develop products and optimize the process to manufacture them on an industrial scale. With the increasing sophistication of manufacturing techniques, process equipment, and monitoring mechanisms, a growing emphasis has been focused on the intellectual creations. This intellectual property, or IP, can take the form of industrial formulas, manufacturing recipes, computer-aided designs, and advanced machine configurations, and are often where a large proportion of a value in manufacturing and process industries now reside. The protection of these assets in life is therefore crucial. So firstly, I'd like to provide a brief introduction to Cumulocity. Cumulocity was born in an innovation initiative inside Nokia, which was focused on making carrier-grade network management systems applicable to the requirements and economics of the evolving machine-to-machine market. The organization grew rapidly through its successes and won numerous industry awards before being spun off, but still backed, in Nokia's 2012 reorganization. Today, Nokia serves over 100 enterprise customers using over 1,000 tenants and supports over 2,500 developers around the world. Nokia strives to remove the complexity and cost from IoT and allow the benefits to be exploited rapidly, comprehensively, and securely by all organizations. We offer a fully featured Internet of Things platform product, which covers 80 to 90% of the requirements of most customers out of the box. The remaining 10 to 20% can be easily developed using our open APIs, plugins, and application integration. Our IoT platform is inherently carrier-grade for security, reliability, and availability, and is both device and network agnostic. It can be deployed across 20 global cloud hubs on 5 continents or on-premise in the customer site or as a hybrid of both. Now, no webinar about IoT security would be complete without sharing some more details about the security inherent in our IoT platform. So Cumulocity designs security in from the start with leading-edge technologies and techniques employed at every layer in the technology stack. Native multi-tenancy ensures that each organization's data is separated whilst allowing it to run on the same software instance. Device as the client ensures that the device takes control of its communications and is not accessible by anything other than the platform. Multi-factor authentication is available to provide an additional mechanism to ensure user authenticity. We regularly are security audited by independent security consultants, with our IoT platform passing many industry security benchmarks, including Deutsche Telekom's privacy and security assessment, and are recognized as having higher security than some online banks. At Cumulocity, we feel that the Internet of Things is about partners, and Cumulocity is continuously leveraging and building out its leading partner network. As a horizontal platform provider, we are involved in many vertical markets and continuously bring the ingenious, innovative approaches of one market to another and all the others we're working in. Our IoT platform is white-labeled by many partners around the world. We have the devices from many manufacturers pre-integrated and open-source agents for the most common device platforms. The breadth of our network, application systems integrator, and independent software vendor partnerships helps us solve the customer's common problem, enterprise digitization. I'd like to now hand over to James Penny to introduce Device Authority.
Yes, thank you, Phil. So Device Authority is a IoT security company that provides an automation platform to help organizations reduce the complexities, the cost, and the time to market for delivering and deploying Internet of Things solutions by providing a secure device-bound authentication and device registration process coupled with end-to-end encryption solution using out-of-the-box components that are ready to install on these devices and check those security boxes. So a brief history of Device Authority. We obviously have spent the last few years aligning with strategic partners. You'll see some big names on this sort of history chart here, but obviously there are the likes of the IoT platform providers such as Cumulocity, and as well you'll notice the other security vendors along this timeline such as Symantec and DigiCert, who really use the Device Authority solution to drive greater value around some of their existing PKI implementations. And there's also the big name hardware and chipset manufacturers that you can also see here, such as Intel and Dell, who we're working very closely with to provide certified security solutions for their particular products. So if I just explain sort of the Device Authority solution sets, these are the four sort of pillars and the solutions that are delivered as part of the security enablement and automation platform that we call Device Authority Keyscaler. And these all segue quite nicely into each other. So if we start at the top left, the secure device registration and provisioning, and now this solution really helps you solve the challenge of onboarding devices at first boot straight out of that manufacturing plant. So once this device is coming on for the first time, there's kind of a chicken and egg situation around, do I trust a device that is not previously known to these systems? And Device Authority helps solve that problem by creating a device-derived registration process that's based on sort of whitelisting these devices into your ecosystem. And as part of that, the provisioning of these devices to get them configured and set up with the assets and credentials that they need to do their jobs properly in the wild. For example, generating PKI certificates and getting those delivered down to each device. Now, post-registration, the credential management, moving to the bottom left quadrant here, focuses on the management of those assets for the lifetime of that device. So, for example, securely storing those credentials, whether it's username and password or a certificate on that device, even in the absence of a TPM. Moving on from that, the actual management of that at the time of renewal. So with this solution, it is possible to create shorter-lived certificates to reduce that attack surface within your devices that they use to authenticate to third-party platforms. So the solution actually takes care of the renewal and the reprovisioning of these certificates at renewal time. And also revoking these certificates as well. So when a device within device authority enters a quarantine state, we can actually propagate that information out to your credential providers such as PKI vendors or other identity systems to revoke those credentials within their systems too. Moving to the top right, the policy-driven encryption solution allows organizations to deliver end-to-end data-centric encryption for the data that's moving between IoT devices and either other IoT devices or the back-end services. So by actually encrypting the data itself, instead of just relying on transport layer security, we can actually persist the security around the data regardless of the number of third-party ecosystems that data might move through on its journey. And the fourth, in the bottom right here, is the secure over-the-air updates, which is our ability to encrypt update packages for devices, and the option to tie that update to a specific device or subset of devices, and then also provide data integrity validation around those updates to make sure they didn't come from a malicious source, and make sure someone's not trying to apply additional functionality to their device that you didn't intend from manufacturing time. If I just quickly show you this the sort of architecture overview of the device authority Keyscaler platform. So moving from the top, you'll see the management control panel. This is the administrative interface that your admins log into to manage the authorization state of their devices, provision new devices, set up end-to-end encryption policies, and also get a view of the security dashboard for logging and auditing and security notifications within the environment. That connects down into the device authority engine, which is obviously the brain of the sort of entire operation here, which provide the actual device authentication services, the server-side authorization and policy enforcement, management of keys within the entire system, and again that credential management functionality that I referenced in the previous slide. There is a software element you can see in the top left here, which lives on the devices typically, and that software element connects into our service access controller, which is a service appropriate for deploying into the DMZ and allows you to facilitate those external connections. And then finally, at the bottom here, are service connectors, which are modularized components that allow us to efficiently and quickly integrate with our third-party partners. Okay, Phil.
Great. So thank you, James. So what do we consider to be industrial intellectual property? And also, why do we think it should be secured? The recent decades have seen a massive boom in innovation in manufacturing, with the adoption of flexible manufacturing at large volumes in the 1980s, lean techniques in the 1990s, and high penetration of robotics shortly after. And then today, increasingly, semi-autonomous machines are starting to be deployed. These technologies and techniques have radically increased manufacturing efficiency and product quality at the same time as reducing wastage and rework. This results in it being increasingly rare to see a single person in a modern manufacturing plant. These gains have not only been limited to the manufacturers of solid products, with drinks manufacturing processes also taken advantage. Organizations in this area are starting to use sensing technologies to detect the slight variations of the drink ingredients and process operation, so they can make micro adjustments to the mixture and ensure greater and more consistent drink quality. during all phases of the machine's operation. In the past, process machines have had an extended stabilization period, which this resolves. Also, more recent developments, such as 3D printing, have created new opportunities in manufacturing, but also new challenges to those manufacturing organizations. It has enabled rapid prototyping of mechanical designs, be they product components or manufacturing components, but also significantly reduced the costs to duplicate highly sophisticated product designs. Now, numerous factors are continuously driving the innovation in manufacturing. The continuous necessity to drive efficiency and effectiveness to new levels is increasing the amount of automation in the whole value chain, not just on the factory floor. Organizations recognize that costs of manufacturing equipment can only be reduced through volume production and commoditization, with an increasing number of niche specialists appearing to supply the demand. In some instances where logistics costs are so great or local requirements are so broad, an increasing number of smaller local flexible manufacturers are appearing to act as local manufacturers of the designs from larger organizations. This satisfies not only the demand for the original product in that local area, but also the spare parts market, which in some areas could be quite extensive. These trends are creating a fundamental shift in what most manufacturing organizations consider to be their core competence and its associated value. In essence, manufacturing organizations are increasingly associating greater value to their intellectual property than that of their plant and infrastructure, which historically they've associated as being their greatest value. The intellectual property itself is embedded within many areas of the organization's business, but can be most easily seen as sophisticated product and manufacturing equipment designs, production processes, and configurations of the manufacturing plant and infrastructure. So how can IoT help? And in particular, how can it help us securely deploy and manage this industrial and its intellectual property? So a good analogy to take is with copyright management that's been around for some considerable time. In this concept, there is a creator of the intellectual property and a consumer or user of that material. The intellectual property is created and would go through an identification and registration process prior to being used and stored for use, with the creator being informed that it is available to be used. The user would then request use of the intellectual property through a licensing process and would be distributed the intellectual property in the appropriate form if the licensing requirements were met, with the creator getting a notification of its use. A number of security techniques are used in this process, with watermarking to ensure identification of the intellectual property, authentication in the licensing process, and possibly encryption in the distribution of the intellectual property itself. Now, in the highly automated, often robotized domain of modern industrial manufacturing, a number of additional actions are required. The user of the intellectual property is often now the end manufacturing machine, robot, or milling device, with a new actor of customer who is essentially the factory or plant manager managing the deployment of this intellectual property to their manufacturing machines. As the intellectual property in question is extremely sophisticated, an administrator is often required to manage the usage of the intellectual property on behalf of the creator. The intellectual property creation process happens in the same way. However, the usage process requires some extra steps. With the customer's authorization to use the intellectual property possibly requiring confirmation by the administrator, the deployment of the intellectual property being directed to the manufacturing plant or equipment user itself, so the robot or manufacturing equipment itself. Automatic usage information being passed directly back compared against the license, and visible to the administrator. In this situation, the integrity of the information transferred between the intellectual property management system, those middle boxes, and the manufacturing plant or equipment is key, with encryption often being essential. So the securing of the industrial intellectual property in this manner isn't without its challenges. Firstly, the creation of a secured encrypted channel between the systems holding the intellectual property and the large volume of assets requiring its usage requires a trust relationship to be created between them. How can this be done and done effectively? Secondly, there are multiple users of the intellectual property and its usage information. How can this information be secured from end to end in a way that not only authorized users have access to the information, and only those users have access to information and it's actually readable to them? And as the licensing is likely to require some knowledge of the usage, even if a fee is not directly related to it, how can usage information be brought back from the asset in a way that its accuracy is irrefutable? So I'll quickly hand over to James to go through how these problems can be approached.
Sure, thank you, Phil. So how do we create the end-to-end trust relationship, either between devices or from that asset creation to the consumption? Well, firstly, we need to establish and utilize some kind of trust authority. Historically, this has been a certificate authority or a PKI vendor. Today, in the demo, we'll be using obviously device authority, can also act as that trust authority. And what it allows you to do is, create that relationship between you through that actual higher power that's been through the vetting process and applies or conforms to certain standards that we believe to be secure. Second is encrypting that information from end to end. Because even if the trust is there and you can establish that you are sending information to a person, that information can ultimately be tampered or viewed somewhere in the middle. So protecting this information from that creator to the consumer is a vital step in this process. And establishing a strong trust anchor at device enrollment, also to prevent these unauthorized devices from participating in what might be your privatized trusted environment. The idea here is that you can have all the encryption in the world and some of the best implementations for communicating between the creator and the consumer, but if you're letting any device come in and register as a trusted participant, then you're ultimately, it undermines the entire value of the system. So how do we securely control access to that data? Again, data encryption at rest and in transit. And I don't just mean the transport layer stuff here. Again, actually encrypting the message so that you can have cryptographic assurances that your intellectual property wasn't viewed by a malicious individual at any point in time. And this becomes especially important when you talk about data at rest, because that is probably one of the biggest attack vectors for this particular kind of information. This is where it's sort of sitting there. It might not be guarded, or you might think it's guarded appropriately, but there are so many different ways that people can get access to that information once it's sitting there and is not being maybe monitored by a process or something like that. So data encryption at rest and in transit to give you that assurance. And also a sort of a tiered or a granular permissions policy to the actual metadata of that information. I know Phil touched on this on previous slides, but utilizing for instance, the Cumulocity granular permission set to expose certain bits of information about the data that's flowing through the system to perhaps your administrators, but ultimately not giving access to absolutely everyone who's authenticated within the system, because that helps you define that difference between authenticated and actually authorized to view that data. And lastly, the device identity-based authorization. So again, asserting the actual identity of the device or the person that is trying to gain access to that data. If you've got the cryptographic assurance and the encryption of that data at rest and in transit, and you can rest safe in the knowledge that someone has to sort of authenticate themselves and they must be the appropriate owner of that key to decrypt it, that gives you a much greater assurance over who's actually accessing that data, as opposed to simply leaving it in clear text. And the final question, how do we ensure irrefutable evidence from source? Well, there is an obvious strategy here, and that is data signatures and data integrity validation. So using cryptographic techniques and keys, we can obviously create these signatures that provide a mathematical proof that data was signed with a specific private key. And you can verify the integrity of that data and the integrity of the signature based on either having the public key or being able to compute that for instance, hash message authentication code for certain data sets yourself, which is great, and it obviously sets the backbone for what we're talking about here. But you also need key ownership assurance, and what this means is having the relationship between the device and the certificate or the key, the private key, or whatever might be used, and creating that stronger binding between that key material and that device. Because at the end of the day, the key actually verifies that someone had ownership of that key to sign the data, but doesn't necessarily tie itself to the device. So, either through a TPM or the device authority device-bound key provisioning, you need to really create that stronger relationship between the key material itself and the devices to create that key ownership assurance. And finally, that having that identity as well tied back into the centralized system to allow you to look at security notifications, logging and auditing trails to say, yes, device 1 created this data, it was present, it authenticated itself at encryption time, we were able to assert the identity of it, then it sent the information, and at the receiving end being able to say, yep, you are definitely device 2, you are authorized to access this information, and have appropriate permissions to consume it, and creating those security notifications and events, and that breadcrumb trail of all the actions for this particular sensitive information.
Great, thank you, James. So, as you've seen, security needs to be considered at each layer in the technology stack. The combination of Cumulocity and Device Authority comprehensively tackles security at each layer. With every layer up to including the application layer, the security is provided by Cumulocity and our hosting partner, be that Amazon, Microsoft, or an organization's own IT department for our on-premises deployment. And the comprehensive end-to-end security service is provided by Device Authority. So how would would a solution look like in real life? So for example, Acme Manufacturing would like to connect its manufacturing machines. To do this, it could use Cumulocity's IoT platform to rapidly connect the assets, manage their data, and extend the workflows across the two. When we want to start transferring business-critical intellectual property, We would also want to consider the usage of Device Authority's IoT security platform. This can provide the end-to-end encryption from inside the Acme manufacturing IT systems to inside the recipient asset, with the transferred data unreadable to at all parts in between, including on the Cumulocity IoT platform. In fact, the end-to-end encrypted data is only usable on the Cumulocity IoT platform if it is deciphered on the fly for authorized users. And at this point, I'd like to hand back to James.
Yes, thank you, Phil. I believe we should be clear. So I'm going to present an example of the device authority and the Cumulocity integration here. Just to preempt this and set up the scene for what I will be showing you and talking about, we got an example problem statement. So this is very aligned to what Phil has already discussed very well in his previous slides. So we have a connected manufacturing device that's deployed into a facility that's either in a remote location or is owned by a third party. And that manufacturing device periodically receives new data from the research and development department or whoever's coming up with these prototypes to deploy down to that device, have this rapid prototype created and tested in the real world. So to ensure the security of this either CAD files or whatever we might be sending down, we're going to provide end-to-end data encryption between the creation process and the consumption process that Phil detailed. And as part of that, we're going to authenticate to the device authority platform both participants within this particular end-to-end encryption demo. And we're going to also then show the devices receiving appropriate permissions and being able to decrypt that data, and then subsequently send back the acknowledgement of data consumption back to the original sending party. So we're going to show the first server, which is typically deployed within the internal network. This has got a device authority agent sitting on it, and it's going to encrypt the data at source and then deliver it up to the Cumulocity platform. Then we're going to notify the endpoint device that it has a new file and tell it to download that file, decrypt it, and process it accordingly. As part of that decrypting process, again, that device at that manufacturing plant will authenticate itself and decrypt the file based on its permissions, and then send back an encrypted acknowledgement back to the Cumulocity platform, which will be sent on to the original sending party. So what this actually looks like from an overview perspective is we have Acme manufacturing, again on the left-hand side of the diagram that Phil's already spoken to. We're going to authenticate that server. That's when the encryption takes place. We'll encrypt that data, send it to Cumulocity. It will then sit in Cumulocity's file repository in an encrypted state. The end device will be notified that that file is there. The device will download that data, authenticate itself, gain authorization to consume that file, and then decrypt it and use it. For some reason I can't seem to see my cursor here. There we go, that's what I wanted. Apologies for that. So we have these two devices that are already registered within the device authority platform. You'll see it's called a Cumulocity device appropriately and Cumulocity encryption service. The Cumulocity encryption service is at the Acme manufacturing. This is the server that lives within the R&D department that's responsible for encrypting the files. The Cumulocity device is at the manufacturer site and will be responsible for consuming and decrypting these files. If we take a look inside Cumulocity's platform, you'll see there are no files currently in the file repository. That's ultimately where our encrypted file will end up. And we're going to utilize the Events API to broker that new file notification as well as the file consumption acknowledgement. So if we go to the endpoint device, so this is the device connected inside the manufacturing space. On here, we're going to start the device authority and Cumulocity agent, and this will place it into an authorized state, and it's now ready to receive these files from that Cumulocity platform. And then if we move to the Acme manufacturing plant, so we're going to start a service that will automatically pick up files that are being placed onto the server. It will encrypt those files and then send them to Cumulocity. You'll see here it's monitoring the /root/upload directory for new files. And here I have a file connection or an SFTP connection to that particular server. So this is our example data. This is a JSON packet which contains some information to be delivered down to that device. So I'm at Acme Manufacturing. I placed my new prototype or mix onto that server, and you'll see here that the device authority agent and the Cumulocity agent found the new file. It's called data.json. It authenticates the server to derive an appropriate crypto key using the device authority's device-derived crypto. It successfully finished the encryption. It then automatically uploaded that file to the Cumulocity file repository and then generated an event notification for that endpoint device, telling it that there's a new file available. So on the endpoint device, this receives a notification of a new encrypted file, and you'll see that it downloaded the file from the Cumulocity platform, and then it authenticated the device. It authorized it. It got authorization. There is a policy that says that this device is allowed to decrypt files that are coming from that specific Acme manufacturing R&D department. And it successfully finished the decryption process. After that, it generates a file consumption notification, which it in turn has encrypted itself and sent that back to the Cumulocity platform. And if we take a look on the actual file system of that device, we can see our original data.json that was placed on the server at the Acme manufacturing internal network. So then here, back at the Acme manufacturing facility, we can see that it received an encrypted notification from that device. So this is our irrefutable evidence that the device has taken that data, it's decrypted it, and it's managed to place it into its factory process. And you'll see it came through as an encrypted notification. And again, this particular server has authority and permissions to decrypt information coming from that device. So it's authenticated itself, it's decrypted it, and the message ultimately ended up saying, Cumulocity device, the file data.json.enc was consumed one time. And if we go to the Cumulocity platform, we can see evidence of this entire trail. So you'll see we have two notifications now. So the first notification was a notification for the endpoint device to say that there is a new encrypted file available. This contains the file name and the URL where it can download it. And the second notification was that data consumption acknowledgement. So this is, as you can see, it's ciphertext. This is the information that says, yep, I was this device and I successfully consumed that data as part of my process. And if we take a look inside the file repository, you'll see we have our new data.json.enc. No prizes for guessing what ENC stands for. And if we open that and take a look, this is the file as it sits within Cumulocity. As you can see, it's all ciphertext, means nothing to anyone unless you are an authenticated and authorized device within that platform. Okay, so I'm back to Rosa.
Thanks, James, and thanks, Phil. So, yeah, this is just a chance for everyone. If you haven't submitted your question already, this is just your chance to submit any questions you have for Phil or for James. I've been monitoring a couple of questions that have already been raised throughout the webinar, so I'll just come and ask you some now. So obviously we've been speaking here about an industrial use case, but actually some of the audience are asking what other scenarios would you use this joint device authority and Cumulocity solution?
So James, maybe if I start. So
Yeah, sure.
from Cumulocity's point of view, we're seeing a number of use cases come up that require this element, both elements. So the encrypted data download, but also the irrefutable evidence. One of these is that was recently raised to me was regarding car crashes. So there's a large number of cameras now in cars, especially in large vehicle fleets, and this capability to actually encrypt the data that actually comes back from those cameras when there is a crash. And there's a large number of some companies around Europe who are actually sort of streaming the data. When they detect a crash in the car, an accident in the car, they send the data back before there's a terminal fault, obviously for fire, etc., in that vehicle. And that's used to determine the cause of the incident, who's actually at fault, and many other things. So I suppose the legal premise is having that irrefutable evidence that it did come from that source. It couldn't have been tampered with prior to being used in a court or through legal proceedings. Is extremely valuable.
Yeah, I think it's a very good and prominent use case that I mean echo the sentiments for. Obviously, with the announcement recently that Tesla is going to be providing all this auto-driving hardware as well, there's an increased requirement for security, especially in vehicle-to-vehicle and vehicle-to infrastructure deployments. And the user-based insurance is another really good example of that. You know, the insurance, a car is a car, but your insurance is kind of what ties the user down to that specific device. And once the user becomes involved, you know, that's obviously becomes a case for regulatory action and compliance. So yeah, I think it's a really good example.
Okay, thanks. I've just got another two questions here, which kind of go hand in hand. So, obviously, quite interested in the joint solution. So, firstly, they're just asking, what you've just demoed. Obviously, is that available, ready to deploy as such today?
Yes, yeah. So what I've actually shown here and the device authority agents that were deployed to those particular devices are freely available. You know, it's interacting with the Cumulocity API. They have a great set of developer instructions. But yeah, this is absolutely available today. No problem.
And then, sort of following on from that, is just whether so someone's sort of picked up on, James, the fact that you went through the whole of the sort of the key scalar solutions. So obviously the demo focused very much on sort of the encryption and authentication, but will the remaining solutions, sort of looking at the certificates, will that eventually be available as well through Cumulocity?
Yes, so all of the solutions that we discussed I mean, are available today, and you know, encourage anyone who wishes to learn anything more about them, either from a technical standpoint or an implementation standpoint, to reach out. But absolutely, I mean, those are our cornerstone of the Keyscaler product. The actual press release for which I think was a couple of weeks ago that we actually announced it, and that was our announcement of the availability of those solutions. So the technology is all there, the products are all there today. So absolutely, I mean, if there are any, if there is anyone who wants to discuss them offline, then please feel free to reach out.
Okay, and is that also in joint with? I think what they're asking is if they are already a Cumulocity user, if they're already if they're already using the Cumulocity platform for their IoT projects.
Yes, absolutely. So,
Okay.
so there will obviously be an undertaking of trying to understand exactly what they might be using the Cumulocity platform for. No use cases are typically alike, but for the bulk of the groundwork and the device authority solution gets you that 90% of the way to, as I mentioned before, really reduce those complexities. So, absolutely, yes.
Okay, thanks.
Maybe also to add from a Cumulocity perspective. So Cumulocity has a philosophy to have kind of open, publicly available documentation. So we're evolving that in partnership with Device Authority on the integration side, and actually how we can have things work, and also sort of show some of the things we're doing behind the scenes to make this integration, this facility even better. So that documentation will be available relatively shortly. So please look at both the Device Authority but also the Cumulocity Developer Center for more information about in the coming days.
Great, thank you, Phil, and thank you, James, for answering those questions as well. Any questions we have not been able to answer, we will answer individually later this week. We've now actually come to the end of the webinar, so a big thank you to Phil and James, and actually thank you to everyone for their time and their interest, and we look forward to speaking to